We did it. 3 months, 28 live streams, and almost 60 hours is what it took to rewrite the shopping cart application from the book Practical Functional Programming in Scala by Gabriel Volpe. And the only question is, was it worth it? I'm glad you asked. Let's find out. Hey, Vlad here from DevInsideYou.com. Welcome to another video. I know that many of you don't care about the details. All you want to know is whether it compiles faster, but the answer is it's complicated. And I'm not stalling, I swear. The TLDR is that it's pulling its weight. The diamond architecture, same as any other pattern tool or what have you, has its price. In order to get the benefits, we actually needed to write more boilerplate, and so we did. And the good thing is that the compilation time didn't go up. The end result is actually better than I thought. Let's dive into the details right after the message from our sponsors, which is people like you. People who support me on Patreon. You help me pay for a video editor who frees up some of my time, which I choose to spend again with you, whether it's during live streams or answering your questions on Discord. And if you're not one of those lovely people yet, I would like you to know that all it takes is $1. There's many of you and only one of me, so eventually it adds up. Thank you. Alright, now here's the plan for today, and as always I'm trying to make this video short. First I'm going to show you the new dependency graph and explain a couple of details. Then we're going to have some b-roll with the proof of compilation time, and then eventually I'm going to walk you through a couple of places in the code. I'm not going to show you the whole thing because you can just check it out on GitHub. It was like 28 live streams, 60 hours, so I'm not going to show you the whole thing. I'm just going to point out a couple of very, very important details, okay? Well, let's have a look at the dependency graph. And I actually created a diagram, and I included it as part of the repo, okay? So the link is going to be down in the description. So let me actually make it a little bit smaller. So it's github.com/devinsideyou. Then, this is a fork of the shopping cart, and then it's on the diamonds branch. And, you can have a look at the commits as well. So these are the ones that we did during the live streams. It was like day 26, 27, 28, okay? And so if you scroll down over here, I have included two dependency graphs. They're the same ones. It's just that if you're using a dark theme, use the one with the white arrows. And if you're using a light theme, then use the one with the black arrows. Okay, so I'm just going to open this one. As you can see, as I have explained it in the previous video, but, those videos it's been already like a couple of months, maybe you don't remember. So all the arrows point to the core. I used to have the core at the top. Now I have only the core headers, which is just, just the traits, and the implementation of the core is actually over here, okay? So the core headers is at the top. All the arrows point to the core headers. At the bottom, we have the main with the dependency graph, and the reason why they are red is because they are the choke points. Okay, we're going to talk about this a bit later, okay? The application is being delivered over here with the team blue, and the implementation of all of these core headers is team green. Team yellow are the utilities. So first things first, if you remember from the previous video, I actually tried to split the core headers into input headers and output headers. Over here, I decided that it's not worth it. I'm just going to make the trade-off, core headers compiles fast enough for me. I don't think it's worth it to complicate the build, the dependency graph so much just to get like a couple of milliseconds out of it. So I didn't do this input output headers. It's just core headers, okay? Which means that we have the gates over there, which are now called dependencies, and also we have the boundaries, which is something that the delivery portion of the application needs to go through in order to talk to the business logic of the application. Team green is pretty much self-explanatory, right? So those are the implementations of the traits that are over here. There is a facade on top of them called dependencies, used to be called gate, and the boundary implementation that is now over here uses this facade to provide functionality to the delivery portion of the application, which, as you can see, it's an HTTP application, and we use HTTP4S for it. By the way, I kind of forgot to mention, so the team yellow is the utilities, and they happened to also have a dependency on the core headers, which is why they're in the middle. And the reason for that is that we abstracted away logging, so we have a trait logging somewhere over here, and both JSON Cersei and the retries, which uses Cat's retry, both use logging, which is why team yellow is kind of like in the middle. Now, team green is pretty much self-explanatory, except for two things that I'm going to mention over here. One is the core, as already mentioned. I just moved it out so that the delivery portion doesn't have to wait for it to compile because it doesn't care about the implementation. It just needs to know the header, right, the trait, okay? And the other one is core adapters. And core adapters is a little bit harder to explain. I believe the second video was actually about it, but I'm going to show this to you later in the code. Essentially, the goal of this is that if I have one use case that depends on another use case, I don't want to see it until I'm doing dependency injection. Okay, so I want to see it only there. Now, I know it's a little bit hard to imagine, but don't worry, it's all going to become clear a bit later when we're going to have a look at the code. Another thing that I would like to point out is the JSON search over here. So the way we did it is that we actually have codecs over here for the domain objects. Usually this is not how I would go about this, but nothing is perfect. There's always a trade-off. So this way it's faster to implement because you don't have to create any data transfer objects. Like usually I would use something like Chimney, but even though this was a Scala 2 project, and Chimney is not published for Scala 3, but even though this was a Scala 2 project, I decided not to add it just to not overcomplicate things. Okay, so as you can see, a bunch of things, like for example, this one, and this one, and also obviously the delivery, they all have a dependency on JSON, and also they all require some kinds of codec, right? Even the persistence, because like these days, Postgres can store JSON. One huge caveat of having codecs over here for your domain objects is that even though it's like faster to code because you have like less boilerplate to write, it's actually very dangerous because, the codecs are being generated with libraries like Cersei, right? They're being generated at compile time with macros and stuff. So what happens is that now you're afraid to do like a simple rename refactoring or like simply like adding a field to a case class or like removing a field from a case class because, you'll fix the compilation errors, the codecs will be regenerated, but now you have broken the backwards compatibility of your HTTP API. Have a look at something like golden testing. It's also sometimes called as a snapshot testing. And I have a video about it specifically for Cersei. This will help you to mitigate this issue. But usually like, in a bulletproof application, I would actually create data transfer objects. Unless it's some like, really huge trees of ADTs, then I would make the trade-off again because it's a pain in the neck to copy paste like huge ADTs. Okay, so for ADTs, I would make exceptions. Another thing that I would like to point out is the naming. If you remember from the first video, I mentioned that the diamond architecture is not just the architecture; it's also a guideline for naming conventions and where to put things and stuff. And so just by looking at this picture, you kind of see, okay, this is a type level stack application, but you also see more things. You see, okay, it's being delivered only via HTTP. We don't have like any message queues. We don't have any schedulers. You see it immediately. You also see that, for example, like we're loading the config from the environment variables by using Cyrus. I believe Cyrus cannot read from files. I might be wrong. Probably it can. It has some adapters and stuff, but usually it reads from environment variables, as opposed to files. We're using Postgres, and for this we use Skunk. We do some cryptography stuff, and for this we use this weirdly called library. The core adapter is complicated. Core is, it's not as complicated, but it's kind of easy to imagine. You used to be over there, now it's over here. We also making some other HTTP requests to potentially third-party APIs, and we also use HTTP4S for it. But over here is the server, over here is the client. We use Redis for cache. We use JWT PDI for authentication and so on. We use cats retry for retries, and we see exactly even where we do the retries. We see, okay, it's only in the persistence. Okay, so we have a lot of information, and this is very useful for things like due diligence, even though it it doesn't show licenses, but it's also extremely helpful when you're onboarding somebody new, right? You can just show them this, and they kind of know where things are, where to put new things, which is very, very important. And also in general, it just gives you like this bird eye view on the stack and on the entire architecture. All right, so it's time to talk about the compilation time. But before we continue, I would like to point out two things. The first one is that whenever I change something, this is by no means critique on Gabriel's work. I already have reviewed his book, and if you remember, I loved it. And also he offered to send me a review copy of his upcoming book, and I insisted that it's not necessary because I'm gonna buy it anyway, and also eventually I'm gonna make a review of it as well. So don't forget to subscribe, click the bell if you want to be annoyed when new videos come out. The second thing that I would like to point out that this entire application turned out to be too tiny to prove the effectiveness of the diamond architecture, at least the effectiveness in terms of the compilation time. So one day I should probably take something bigger, but I don't think that we ever will. And I'll say a couple of more things about this a bit later. So we have three versions. The original one that I ironically called the big ball of mud. Again, this is not some passive-aggressive critique on Gabriel's work. It's just to denote the fact that it's all like in one SPT project. Okay. Then the second version, which we're going to call the diamond architecture, this is the one with a multi-build, right? The one that I just showed, with a bunch of boxes, as I like to call them. And the third one is the one that I called The small ball of mud is the one where I have the diamond architecture, right? But I took all of the files from this multi-build and I crammed all of them into one, right? So it's a single build again, similar to what Gabriel did, right? But so it's basically just flattened. It's actually ironic that I call it small ball of mud because it actually contains 3 times more files. Imagine my surprise when I found out that all of these 3 versions take exactly the same time to compile, within like maybe 1 second. Now, when I'm not recording, it takes around 30 seconds. When I am recording, it really depends on how hot it is in the room. I've seen times of like 35 seconds, and I've also seen times of 45 seconds. But the most important point is that when one of them takes 35 seconds, the other one takes 35 seconds as well. When one of them takes 45 seconds, the other ones take 45 seconds as well. So all of them take exactly the same time to compile on a 4-year-old laptop. By the way, I imagine that around this time you're going to see a bunch of B-roll, and I'm sure that you're curious which tool this is at the bottom, and it's actually called Bottom. I'm going to leave a link down in the description. Now, I was surprised because the rewritten version is actually much larger. We tripled the number of files, and we have 40% more lines of code. Now, none of those metrics are reliable, and so everything within like, I don't know, like 10 seconds of difference in compilation time is very neglectable. And yet, all of them took roughly the same time to compile. How crazy is that? Now, I'm sure that some of you are surprised. You were expecting the diamond architecture to compile even faster than the original version, so why didn't it? And the reason is, as already mentioned, the application is too tiny. The portion that was actually compiled in parallel took only 1/4 of the entire time, right? So the main and the core headers, which are the main choke points, took the majority of the time, right? The core headers to actually half, the main took 1/4, and this parallel point, you know, everything like all of these boxes compiled in parallel took another 1/4, right? So if everything was like taking 40 seconds, then it was like 20 seconds for the core headers, 10 seconds for the main, and another 10 seconds for this stuff in parallel. So we just don't have enough code to compile in parallel. It's very, very tiny boxes, even though we had like, what, like 6 or 7 of them? So if we wanted to truly prove the reduction of the compilation time, we'd need a bigger boat, but I doubt that we'd ever get one. There's just one thing that I would like to mention before we have a look at the code, and it's the fact that because the multi-build version takes the same time to compile as a single build version, you might be tempted to use a single build, and so I would like to explain why I think it's a bad idea. There are basically 2 major reasons. One, if you have a multi-build, it's much easier for IDEs. They have to switch to the presentation compiler less often. This in particular is noticeable with metals. You know, if you have everything in one thing, if there is a compilation error somewhere, sometimes like nothing works, and so multi-build saves you from it sometimes. Number 2, and this point is probably the most important in this entire video and probably in this entire series, is the fact that our guinea pig was too good. This was a perfectly prepared application from a book. It was incredibly high quality to begin with, which is also why we almost didn't get any benefits from the rewrite. Now, I hope that I don't need to tell you this, but out there, most applications look nothing like applications from educational materials like books. It's anything but clean. The dependencies point in the wrong directions, there are cycles that slow everything down, and so on. So I would like you to start thinking about builds as extensions to type systems. Imagine the following scenario. Let's take a gigantic application, like 30,000 files, like millions of lines of code, okay? But the build is perfect, like from book, type to the max, test it to the max. Now, imagine if there is a way to turn off the type checker phase in the compiler, to remove all of the tests, and to take the entire build and smash all the files into one. Same as I did with the diamond architecture, right? I smashed them all into one, and, you know, small big ball of mud came out. Now, what happens is that everything still works, right? You can deploy it, everything is fine, right? But now try to maintain it. Very different story. Everything is smashed into one, you have no types, you have no tests. Have fun. So to sum it up, take care of your build, take care of your types, take care of your tests, and in return, they'll take care of you. This is pretty much everything that I wanted to say, but for the curious ones, I'm going to point out a couple of things in the code, okay? But it's all on GitHub, so you can have a look at your own pace, okay? So this is what we have over here. This is the entire directory structure. So this is the old code, right? So there's like app, and there's like modules, there's like core, source, Scala, shop, and, you know, we had like the modules over here. This is actually the wrong one. Hold on. So there's like programs, which is checkout, and also Gabriel made a distinction between programs and services. Okay, I didn't make this distinction. Okay, so for me, all of this is business logic. So the checkout is business logic for me, and all of this is business logic for me, even though most of the time it would just like forward to the dependencies. Okay, so this is the old one. This is the diamond architecture, right? C stands for utils, I stands for input, right? So this is team blue, this is team yellow, and O stands for output. Okay, so I just wanted to have them all sorted. As a reminder, these numbers, they're not technically layers, right? They're just sort of like a grid, right? So to show, okay, there's like core headers at the top, main at the bottom, everything else is in between. Okay, and the reason I chose these letters is so that they're also alphabetically sorted. Remember, like team yellow was like kind of like at the top, and then these ones are at the bottom. By the way, I'm actually noticing right now that this one should actually be called O core. Okay, so this actually should be O-core like this, which means that we also need to go to the build and we need to change it real quick. So we need to search for project core. Lazy val core, like this. So as you can see, this should be O-core, like that. Yes, please import the changes, and let's also commit this real quick. So let's see. I kind of want to shove it in over here, so I'm gonna put it over there. Hold on, over there. Okay, like this, and over here. It's going to be a fix-up, so we're just going to do this, and there are some conflicts. How can there be conflicts? Oh, this is the new thing. Oh yeah, I know what I did. I know what I did wrong. It's just like out of habit, I rebased against origin master. So hold on, close, blah, blah, blah. Okay, so GRBA to abort the rebase, and I would like to rebase against, let's just do something like this. Much better. There we go. All right, so let's just push it. That didn't happen. Okay, there we go. All right, cool. So import build, just in case we mess something up. All right. So the first thing, this whole thing is a techless final application. Okay. And as already mentioned, I just want to point out like just a couple of things. So I'm just going to walk you through the new thing. Okay. So we have a main, which I'm actually not super happy with. I call the entire package shoppy, by the way, right? So it kind of looks like this. We're just creating a program, and the program is like this. So I'm not super happy with this thing. Okay, so part of it is because it's like techless final, and some things like had to be implicit, and so I kind of had to like hard code them like this. I say hard code, but I mean like it was easier to have like an implicit val instead of passing it around as a context bound. If you have seen my recent videos about like techless final versus Zio, I've sort of like given up on techless final. I hope that this is the last time I have to do this. I mean, I have to do this at work, but that's a different story, right? Like hopefully like on stream and everything, we're only going to do Scala 3. And if we do need to create something bigger and with us need functional programming, hopefully we're going to be able to just use Zio. I don't want to spend too much time over here, but essentially we're loading the environment config basically to figure out whether it's a production level application or if it's a local application. Based on that, we're loading the resources, and over there we make the decision, for example, for the HTTP client, whether to talk to the real external API or not, right? None of this stuff is actually important. So this is a bunch of resources, and then we run the HTTP server forever under supervision. So we're creating like this supervisor thing, and then we do like, make HTTP server and then serve. Make HTTP servers over here. So this is the one that creates like a bunch of things that the use cases require, right? So actually the more important thing that I want to show you is over here, right? So this is like where like the more like clean stuff starts. Okay, so the controllers are just something that has routes. Okay, so if I do like controllers.make over here, we see like this is like a bunch of things that are like required to assemble my use cases. So this is like the this is where like the clean stuff is. Okay, so every line over here is a use case, and there is one line that I will point out a bit later, maybe even now, is the one that has like these core adapters. Remember, so what happens is that this cart boundary, right? So over here, we're creating a shopping cart dependency injection. We're making it by giving it the Postgres, by giving it the Redis, and by giving it the user authentication. And so usually, like what would come out is just a controller, which again is just something that has routes, okay? And so we just put them all together, and that's it, right? And then, we're giving the routes to the HTTP app. They're all being assembled together. But in this particular case, we're also returning the boundary that that the controller uses, right? So there's the HTTP layer that goes to the boundary to talk to the business logic, and this boundary is being used in another dependency injection point. Okay, so this is why I needed the core adapters. Okay. So I'm going to show you this a little bit later. Let me show you before a couple of, simpler ones. So for example, like over this one, items, right? So most of my dependency graphs look like this, okay? So we're assembling a controller needs a boundary needs a couple of dependencies. In this particular case, it's just a persistence, okay? Most of my dependency injection things look very, very tiny like this. So there is no need for some like MacWire or layers or anything like this. So as you can see, they're all super tiny and they're all like very, very similar. Okay. So usually, we just we're assembling the controller. It needs the boundary, maybe another thing. And the boundary usually needs persistence, sometimes also Redis, another thing. Okay. So let me see what I wanted to show you. Okay. So one thing is this core adapters thing. Okay. So when we're assembling this shopping cart thing, okay, so what we have over there is this boundary, okay? So the type of this boundary is, well, it's just boundary, great. So if we go over here, we're going to see that it returns this specific boundary, okay? So this is the shopping cart boundary. So we can do like add, get, remove item, and update. If we were to compare this with the shopping cart, an equivalent shopping cart service, as Gabriel called it, we're going to see that there will be one more method. So this is actually a super important thing. And the reason why Gabriel did it is because he didn't treat it as business logic, which is fine. It's just that I prefer not to make this distinction. So for him, it's like services and orders, okay? And as you can see, hold on, shopping cart, okay? So you can see there's one more, okay? Which one? Add, get, remove item, update, add, get, remove item. Okay, so delete, okay? So he treated like this thing as sort of like an active record or sort of like a repository, okay? So basically, like if you look at the implementation, it just like talks to like Redis or whatever. Well, it's actually, in this particular case, it's actually only Redis. It can't be only Redis. It had to be Postgres as well. By the way, this is a new experimental feature in VS Code. It's called like sticky something. I have seen it behave wrong. So basically, it shows you like which scope you're still in if you like keep scrolling down. Okay, so it thinks that we're like in the ad scope, but we're not. So we're actually like in the shopping cart here. So until here, it's fine, but like this last line is wrong. In any case, my point is that if you treat this sort of like as a repository, as like a bucket of things that you can do with a shopping cart, it's fine. However, with the Diamond architecture, it's actually not going to work because eventually you're going to need to do transactions and you're not going to be able to do this, right? It's actually kind of hard to explain. And I was hoping that we would actually have transactions in the shopping cart, and we did, but it was actually not used anywhere. So Gabriel has an example of a transaction. And when I saw it, I was like, oh, cool. So we were going to have a cool example, but it's actually not used. So as you can see, like there's shop, but there's also like here, TX items. As you can see, it's like an example of transactions, but it's not used anywhere in the application. I was really hoping that we could do this so that I can show you what I mean. In any case, my point is that it is very important to use verbs for bounded context, right? So for my like namespaces over here, instead of just nouns. Now, The only exception to this is like CRUD, right? So if it's CRUD, like how else are you going to call it? Well, you can call it CRUD. Great. Okay. So the reason is that if I treat this as a business logic, for this particular use case, I did not need deletion, right? Because where is this boundary used? Well, it's only used in the, it's used in the controller, and it's also used in the other boundaries. This is like Metal's not showing me where it's actually used. So this is the dependency injection for the shopping cart. This is exactly where we use the boundary. Like, why would we use the boundary? Well, because this controller needs it, right? So if we go over here, right, then we're going to see that all of these 4 methods are being used on this boundary, right, which is called dependencies because I hid it behind a facade, right? So if you look at dependencies, you're going to see like 4 methods, right? So you're going to see like add, update, remove item, and get, right? Like these 4. Right? I didn't need the 5th one. I didn't need the deletion. Therefore, I didn't put it on that trait. So if you were to go to the checkout DI, that's Scala. There we go. And we're going to see that over here, in order to implement something of the facade that the business logic of my application needs, I actually needed to inject another boundary. Okay? So this means that if we were to go to this boundary, okay? I don't know why it cannot jump in there. So let's go like checkout boundary. Okay. So if you look over here, like I always have this facade, right? And over here, I'm saying, well, I'm going to have like a facade for other boundaries and I need a get cart total, right? So this is basically a copy pasted function, right? So you can even see like the types over there. Like sometimes I would actually even copy paste the types. Like this is the conversation that we had before. I would even use chimney, so that I never have to like use like my neighboring objects and stuff. Okay. But the point is that in order to implement this get cart total, I actually have to use another dependency, right? Another boundary. Okay. So the implementation for this thing over here is here, right? So in order to implement this other boundaries trait, well, I need to actually have the shopping cart boundary, okay? And this is the implementation, right? So this allows me to like give a better name for this method. This allows me to change the type over here, which I didn't do, but I could, and then transform stuff over here, right? So this is this core adapters thing that we have over here, okay? There's core adapters. So this is essentially, if you see over here, it's in a different thing, right? So it compiles like completely separately. And so you only see that one boundary has dependency on another boundary when you assemble the dependency graph. Honestly, this is pretty much everything that I wanted to show you except for one tiny thing. I made a short like half a year ago or something, where I said that my favorite feature in Scala 3 is exports and top-level definitions. And dear God, was I right? Dear God, do I stand by it? Like, if you have seen me coding this thing live, I was so annoyed by the fact that we cannot have top-level definitions. I have done like crazy things over here to work around this. Because of this, like I really, like in Scala 3, there is a way to never have to import your own thing. Right? Over here, we still have to import sometimes dev inside you. So like this is just a rename because there was like a name conflict. This is fine. But like these things, like in Scala 3, there would be a way to avoid this and not have this import, right? Because I just had like this object called refine somewhere with a bunch of implicits there. Like I really wish that I could like define these things as top level definitions. Okay. And I even have somewhere a thing called package copy. Let me actually search for brand param. I ended up having like to do something like this because, I tried to work with package objects, but they had bugs. And also the problem was this whole thing, like was the way I structure, the namespaces and everything is that if you open like any namespace, right, like checkout, okay? So there's a boundary for checkout. There is persistence for checkout, right? So they're all like spread out over here. So they're all in the same package, right? And therefore it means that I can have only one package object. Okay, in Scala 3, this limitation is lifted, right? So I can have top-level definitions everywhere in any of these boxes. All right, all of this stuff is on GitHub, so have a look. I don't think that we're going to have any more videos about the diamond architecture in the near future. We might have them at some point, but not anytime soon. And so yeah, so now you know how I structure gigantic applications if I write them from scratch, which is a big if. Cool, I hope you enjoyed this one, and I see you in the next one. For now, as always, it's been Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. And if you're serious about improving the developer inside you and you have the means, consider supporting me on GitHub Sponsors or Patreon, and thus watch my videos before everyone else. And most importantly, take care.